Imagine a world where even the most fleeting touch on a bullet casing could unlock the identity of a shooter. For years, that's been a pipe dream in forensic science, a near impossible feat, but what if I told you that dream is now closer to reality than ever before? Scientists have achieved a groundbreaking breakthrough that could revolutionize how we solve gun-related crimes, retrieving fingerprints from fired bullet casings. For decades, the intense heat generated when a gun is fired was believed to obliterate any trace of fingerprints left on the cartridge. The casing, subjected to extreme temperatures and pressures, seemed like an unlikely candidate for yielding such delicate evidence. But researchers at Maynooth University in Ireland refused to accept this limitation. Their relentless pursuit has led to a revolutionary technique that allows them to lift human fingerprints from superheated bullet casings with unprecedented detail. Even more impressively, these aren't just smudged outlines. We're talking about fingerprints appearing at the highest level of detail, including the intricate pores and ridges that make each fingerprint unique. Think about it. Those tiny details, once thought to be lost forever in the fiery discharge of a firearm, can now be recovered and used for identification. This level of precision could dramatically improve the accuracy and reliability of forensic investigations. The research team, led by chemist Eithne Dempsey and her former PhD student, chemist Colm McKeever, didn't actually fire bullets from a gun in their initial experiments. Instead, they carefully heated the casings in a furnace to simulate the conditions of a gunshot. While this might seem like a limitation, it allowed them to isolate the effects of heat on fingerprint residue and perfect their retrieval technique. As Eithne Dempsey boldly claims, finding prints on fired ammunition casings has always been the holy grail in forensic investigation. She explains, traditionally, the intense heat of firing destroys any biological residue. However, our technique has been able to reveal fingerprint ridges that would otherwise remain imperceptible. This is a game-changer because it challenges the long-held assumption that all biological evidence is destroyed by the heat of a gunshot. But here's where it gets controversial. Some experts argue that heat isn't the only factor at play. They believe that the gaseous blowback, produced during firing, the high-pressure gases that escape from the gun, is even more effective at erasing fingerprint evidence. This means that the success achieved in a controlled furnace environment might not translate directly to real-world scenarios where blowback is present. The innovative technique developed by Dempsey and McKeever involves using a special chemical formula and a small amount of voltage, a process known as electrochemistry, to reveal the hidden fingerprint residue. Think of it like developing an old photograph. The chemicals react with the invisible residue to make it visible. And this is the part most people miss. Their technique isn't just for fresh casings. It can even uncover fingerprints on bullet casings that were touched, heated, and stored for over a year. This opens up possibilities for re-examining cold cases and potentially uncovering new evidence. Colm McKeever, now at the Technological University of the Shannon in Ireland, explains the process. Using the burnt material that remains on the surface of the casing as a stencil, we can deposit specific materials in between the gaps, allowing for the visualization. With this method, we have turned the ammunition casing into an electrode, allowing us to drive chemical reactions at the surface of the casing. It's a bit like turning the bullet casing into a tiny, high-tech canvas for revealing hidden secrets. Of course, further testing is crucial to demonstrate that this technique works reliably on bullets actually fired from a gun, with all the complexities of real-world conditions, including the aforementioned gaseous blowback. The researchers acknowledge this limitation and are actively working to refine their method to overcome these challenges. McKeever's and Dempsey's new forensics tool is undoubtedly an exciting step forward, but the quest for the Holy Grail continues. The study, published in Forensic Chemistry, provides a glimpse into a future where even the most challenging pieces of evidence can yield valuable clues. But what do you think? Will this technique truly revolutionize forensic science, or are the challenges posed by gaseous blowback too significant to overcome? Share your thoughts and opinions in the comments below. Let the debate begin.